Hi, I'm Andrew Duchenko, and today I'll be presenting our paper, Spoken ObjectNet, a bias-controlled spoken caption dataset, which has been accepted to Interspeech 2021. This is joint work with the following authors. We consider audiovisual models that learn from spoken captions of images. The main motivation for this research is to enable systems for language acquisition and object recognition in different languages. There are over 7,000 spoken languages in the world, but automatic speech recognition is supported by less than 2% of them, in part due to the large amount of labeled speech data required for each language. Learning from images and spoken captions instead has been shown to enable audiovisual systems that can understand words and relate them to visual objects. The Places audio captions dataset is one of the largest spoken caption datasets. Spoken captions were collected via Amazon Mechanical Turk. Here we can see some example images, the audio of the spoken captions, and the transcripts from the automatic speech recognition system. In our work, we are interested in extending the types of objects and scenes that these audiovisual systems can reason about. Therefore, we collected spoken captions of the images in the ObjectNet dataset. The ObjectNet dataset was proposed as an image dataset with controls on rotation, background, and viewpoints. Here we can see the difference in how chairs are photographed in ImageNet versus ObjectNet. We collected spoken captions for ObjectNet using Amazon Mechanical Turk. Workers were asked to describe shapes, objects, locations, and colors of the images. We used the speech recognition system to count the number of words and rejected recordings without words in real time. We introduced a novel step of using a BERT model with a language modeling head to assign a score to each caption and to reject poorly formed captions. Workers were also prohibited from captioning more than 12K images to prevent speaker bias. In the end, we collected around 50,000 spoken captions, with about 48,000 in the training set, 1,000 in the validation set, and 1,000 in the evaluation set. We split the data such that there's no speaker overlap between any of the sets. In total, there's about 155 hours of audio and about 18,000 unique words. Here we show sample images, audio of the spoken captions, and the automatic speech recognition transcripts from Spoken ObjectNet. Spoken ObjectNet is designed to be a test dataset for audiovisual models. To use the dataset, we suggest training an audiovisual model on some other dataset first. Then evaluate image audio retrieval on the evaluation set of 1,000 pairs of images and spoken captions. ObjectNet license prohibits the training of model parameters on the images. Therefore, only embedding layers in the audio model can be fine-tuned on our training set. We conducted transfer learning experiments from a model trained on Places audio. In the zero-shot setting, the model's mean recall 10 performance decreases from 0.735 on Places to 0.118 on Spoken ObjectNet. This shows that the model trained on Places can be directly applied to Spoken ObjectNet, but the performance is much lower. Fine-tuning the model with a frozen image branch recovers some of the performance, up to a 0.214 mean recall 10. Here we show example retrieval results for two sample query images. In the first example, for the given image, the model retrieves the correct audio caption as the top result. However, for both images, the relevance of the other retrieved audio captions could be improved. To summarize, spoken caption datasets can be used to learn audiovisual representations without manually transcribed speech. We collected a new dataset of spoken captions based on the ObjectNet dataset, which has controls for rotation, background, and viewpoints. Our transfer learning experiments show that the current retrieval performance is much lower on Spoken ObjectNet than on Places audio. Future work may include text-based captioning experiments. Here are additional acknowledgements. Thank you for your attention.